Hello everyone, this side Mayank Jhunjhunwala from IIT Kanpur. So today we are going to discuss inverse trigonometric functions with you. Let's start.
Recording in progress.
Let's start with inverse trigonometric functions. Let's start with the basic trigonometric formulas. See, basically trigonometry comprises of. Let me take the pen first. See, we know that in trigonometry there are six functions: sine, cos, tan, cot, secant, cot. So basically, their inverse functions are only what we study in inverse trigonometry. Basically, inverse functions को हम लोग arc we term them as arc into that function. Means like arc sine, arc cosine, arc tangent, arc cotangent, arc secant, and arc cosecant. So we call them like this, and there are some basic formulas like sine inverse of minus x is minus sine inverse x. Why? Because sine inverse is x is odd function, that's why. Because it's an odd function, that's why we write it like this, and where x is defined from -1 to 1. Similarly, for cos inverse minus x, it is pi minus cos inverse x. For tan inverse minus x, it is minus tan inverse x. Again, why? Because it is an odd function, and so like it goes on. But one thing, remember, you have to learn these things, that in which domain these functions lie, because it's very important. This is the only thing where questions are being made on ITF, so please remember it, and we will study it in the coming slides also regarding domain and range. So let's move ahead. So moving on to arcsine function, what's there in arcsine function? Arcsine function is basically like this. It is defined only from pi by 2 to minus pi by 2. Why? Because if we define it after pi by 2, then my sine function will repeat its value. No, like we know the graph of sine is something like this. It is something like this. No. So we know that for defining an inverse function, we need that the function should be bijective. What is the meaning of bijective? Bijective means it should be 1, 1 and on 2. So it should only take one by value only once. So if we take beyond minus pi by 2, then my values will repeat. And similarly, after pi by 2 also my values start repeating. So I don't want repeated values. That's why I only take my interval from minus pi by 2 to pi by 2. That is from here to here. This is the only interval for my sine inverse x function, otherwise my values will repeat. See, here and here values are repeating. Similarly, here and here values are repeating. So I don't want the values to be repeated, because an inverse function is defined only when my function is 1, 1 and on 2. That's why my arc sine function is defined only from minus pi by 2 to pi by 2. And its graph is something like this, where domain is from -1 to 1, because we know that pi by sine pi by 2 is 1 and sine minus pi by 2 is -1. That's why its domain is -1 to 1, and range is minus pi by 2 to pi by 2, both included. This is very important. You have to include both things. Okay? Similarly here. Okay? So ये होता है मेरा arc sine function. आगे बढ़ता है. Similarly for cosine also. Cosine की values भी ऐसे repeat करती है. Cosine का graph भी देख लो. ऐसे होता है ना cosine का graph. It's something like this. सो यहाँ पे भी वैल्यूज रिपीट करने लगती है एक इंटरवल के बाद, इसलिए इसको मैं जीरो से पाई डिफाइन करता हूँ, जीरो से पाई में, मतलब यहाँ से लेके फ्रॉम हेयर टिल हेयर, फ्रॉम हेयर टिल हेयर. वन सेकेंड. Okay, so my cosine function is also like this. So arc cosine will be something like this, and we know that if we go beyond this pi, again my value starts repeating. See here, my value is repeating, and similarly here, if I go beyond, my value start repeating. So I just take values from 0 to pi here, from this point to this point. ठीक है, तो 0 से pi में मेरी values repeat नहीं करेंगी. That's why I'm taking from 0 to pi, and so domain is from again -1 to 1, because we know that our cos 0 is 1 and cos pi is -1. That is from here to here. So this is my domain, and this is my range. This is my domain, and this is my range from 0 to pi. Okay, so this is my basically arc cosine function. Again, both included. moving ahead. For our tangent function, with similar logic, we take from minus pi by 2 to pi by 2, and here the value will go up to infinity because we know a tan graph, it goes to infinity. Tan graph is something like this, no? It goes to infinity. Then this is a line, then again it goes like this and goes to infinity. So that's why, again, we'll draw a line. This is the graph of tan x, as we all know. So basically, what I take the interval, I take only this value. From this value to this value, it is from minus pi by 2 to pi by 2, and it goes to infinity this side, and it also goes to infinity this side. Take, and so domain is from minus infinity to infinity, and range is from minus pi by 2 to pi by 2. Here, remember one thing, this is not included because including it will say to you that we are reaching infinity, but we can't reach infinity. So basically, it is range from minus pi by 2 to pi by 2 not included. Similarly, domain is from minus infinity to infinity. Okay, so it was our tangent function. I hope you got that. Let's move ahead. Moving on to our cot function, which is in cot inverse function. Similarly, we define cot inverse x. It is defined from 0 to pi again, and the domain is from minus infinity to infinity, and ranges from 0 to pi. So you can see it ranges from 0 to pi, and domain is from minus infinity to infinity because we're defining it in the whole range. It goes like this and goes like this. So domain is from ranges from 0 to pi, and domain is from minus pi to pi, both not included. Similarly, arc function, which is inverse of cos and inverse of sec inverse x. So remember these functions. One thing is very, very important. You have to remember all those graphs because these are very helpful in solving questions. So please remember them. And so this is again arc function made from sec function. So here domain is from minus infinity to minus 1. You can see domain is from minus infinity to minus 1. Why? Because we are going minus infinity here and we are reaching till here, which is minus 1. This point is minus 1. Okay. And similarly, we are starting again from 1 and going to infinity. So that's why domain is from minus infinity to minus 1, both included, and 1 to infinity, both included. And what's the range? Range is basically the values of y. So it is from 0 to pi. You can see that we are going from starting from 0, we are going up to pi, and this line is asymptote, so we are not included this line. This line is nothing but pi by 2. So our answer would be from 0 to pi, both included, but y should not be equal to pi by 2 because at y equal to pi, because at y equal to pi by 2, we are getting an asymptote. That's why our range would be from 0 to pi, and pi by 2 not included. Okay, so it is my arcsec function. Moving ahead, our cosecant function. What is our cosecant function? Our cosecant function is nothing but similarly from made from cosec function. It's again we can see domain. Domain is from minus infinity. See, we are going minus infinity this side, from minus infinity to minus 1, and from 1 to infinity. This is 1, 1 to infinity. Okay, so this is my domain, both included here also, and ranges again you can see from pi by 2 to minus pi by 2. And in the previous our second function, we were getting an asymptote at pi by 2, but here we get an asymptote at 0. So y equal to 0 is not included in my range, and all the included in minus pi by 2 to pi by 2, both included. Okay. So you should remember these graphs. I know you can make it from your logic, but remembering them work it a lot. So move ahead. This is the important properties of ITA functions. Some so let's discuss them one by one. Firstly, we know that cosec is 1 by sine. We know x is cosec x is equal to 1 by sine x. We know it now. Cosec x is equal to 1 upon sine x. Okay, so using that property only, sine inverse x is equal to cosec inverse 1 by x. But 0 is included, as I said, because including 0 will give you cos inverse infinity, which is nothing. That's why 0 is not included. If you learn this property, you should also remember this one where these properties are valid. Otherwise, learning them will not give you any benefit. And similarly for cos is sec inverse 1 by x. It is, remember one thing, it is not 1 upon cosec inverse 1 by x. It's cosec inverse 1 by x. So please don't do mistake there. And similarly, tan inverse x is cot inverse 1 by x, and cot inverse is tan inverse 1 by x. Okay. So these are some important properties. And now coming on to odd and even properties. Like these are for odd and even type of functions. Odd and even. So basically, sine x is an odd function. That's why sine inverse is x. Similarly, tan and cosec. And all the functions cos, sec, and cot inverse are even function. That's why we do it like this: pi minus cot inverse x, pi minus sec inverse x, and pi minus cot inverse x. So please remember this thing: sine, tan, and cosec are all functions. Sine inverse is minus inverse x. Tan inverse minus x is minus tan inverse x. Cosec inverse minus x is minus cosec inverse x. And for all the rest, they have fine everything. Okay. So I hope you got that. Let's move ahead to property set 3. Property set 3, we are like in this question, like what we did sine inverse x equal to cosec inverse by x. Now we are doing here this side and x this side. So basically, sine inverse 1 by x is equal to cosec inverse x. But here the domain is different, and there the domain is also different. Why? Because sine and cosine are defined different domain, as we just studied from the definitions. So sine inverse 1 by x is equal to cos inverse x in this domain. Similarly, cos inverse 1 by x is equal to sec inverse x, and tan inverse 1 by x is equal to minus pi plus cos inverse x. Okay. These properties will actually learn when you will solve questions, because when you will solve questions, this will come again and again, and you will eventually learn them. So moving ahead to property set 4, sine inverse cos theta is pi by 2 minus theta. Again, because we know that sine inverse, we can write cos theta equal to, why this property came, let me tell you. Cos is nothing but sine of pi by 2 minus theta. Okay. So basically, just I have just used it here. So sine inverse and sine will cancel out, and you will be remaining pi by 2 minus theta. That's why. Similarly for cos inverse, tan inverse, all will be done the same way. So these are some basic properties, and you will just tan with cot with tan, and like the function which is written out of bracket, then that and that function will cancel out, and the remaining will be your answer. So these are the important properties, and these properties are very important. Please learn them. This is a certainly different type of diagram. So please learn these two properties. Very important. Okay. So these are like sine inverse x equal to cos inverse of root of 1 minus x squared. Very important property. Similarly, this thing is equal to minus cos inverse root of 1 minus x squared if this is the domain. These property, this is only one property, this domain is different. From minus 1 to 0 it is minus, and from 0 to 1 there is no minus. So please remember it. Property set 5 is something same like we studied sine square x plus cos square x equal to 1. You can remember it from there. Studied in trigonometry, you know that sine square x plus cos square x equal to 1. Sine square x plus cos square x equal to 1. We studied in trigonometry, no? That's why we can say that sine inverse x plus cos inverse x equal to pi by 2, tan cot, and similarly for sec plus cosec. These are also very important set of properties. So please learn them. Then this property like c plus sine d. So it's nothing but sine inverse of x of root of 1 minus 5 square plus y of root of 1 minus x squared is it's rooted whole. And similarly here. Got it? So this is one thing. Similarly, for cosec inverse x plus cos inverse y, it is cos inverse x minus xy minus x root of 1 minus x square into root of 1 minus y square. Okay. So these are some properties which you should be which you know clearly. Now this is one important thing again. A sum of trigonometric series. Sum of trigo series. Okay. So doing it this these two series are very important actually. When you will get summation of sin series and cos series such that their angles are varying by some common difference d. That's a sine 30 plus sine 60 plus sine 90 plus sine 120 with a d of 30 degree. So when the angles are in AP, then the summation of sine series, the answer would be sine nd by 2 upon sine d by 2 into sine of a plus n minus 1 d by 2. Where what is a is the remember it like this. You can also remember like this, that first a is nothing but the first angle. A is nothing but the first angle, okay, and n minus 1 is the number of terms and d by 2 is the common divide. Okay, similarly for cos there is nothing different, just this sign will be replaced by cos and nothing else. Everything will be same as sin in d by 2, sin in d by 2, sin d by 2, sin d by 2. Just this sign will be replaced by cos and everything else would be same. So we get some cos is its formula something like this. So please remember it. These two series are very important, especially for JEE-Mains. They are direct. So please remember these two series. Okay, moving on to method of differences. This is also a method of series. This is also a method of summation of trigo series. So how we do this type of questions? Read in the procedure sentences. Each trigonometric term, each trigonometric term is written as a difference between two trigonometric functions. Trigonometric is given, so we try to write each and every term as as the difference of two trigonometric functions, so that adjacent terms would cancel. It is written that one trigonometric term contains the same function as the integer k. The other numbers contain trigonometric functions subtracted from R or added in R. That is, they basically cancel each other. Like something like this: v1 minus v2 plus v2 minus v3. So basically, adjacent terms would cancel out, and you would be left with only a first and the last term. That's why we write it in this form. So similarly, here it is written vr is fq minus 1. Let's say v1 is this thing, v2 is this thing. So basically, what is happening? Those positive and negative terms are getting cancelled here, 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 here. So basically, what you will be left with the very first term and the very last term. So you will get a you will get to sum easily. So basically, it's nothing but it's just a method of writing the trigonometric terms given in the sum series in the form of difference of two terms, so that you can reach to a final answer. This is also an important method of solving questions. So please remember it. Okay, so moving on to hyperbolic functions. Hyperbolic functions are as such not much important for G-means, but yes, they are. If you know basic formulas, then you are in college basically. So basically, sign of hyperbolic x is e power x minus e power minus x by two. Cos of hyperbolic x is e power x plus e power minus x by two. These are very basic and you should know them. Similarly, tan hyperbolic x is sine upon cos. Cos 1 upon sine, sec is cos, and cot is 1 upon tan. So this is one thing, and here one thing please keep in mind: it should not be equal to 0, otherwise your domain will give domain will not satisfy. That's why. So basically, moving ahead. Once again, there is one more thing here. Tan is nothing but sine upon cos. So basically, these two into two cancel, and you will be left with minus sign and plus sign. So you can learn tan. You can just learn sine and cos, and tan can be given tan can learn just upon like sine upon cos. And similarly, all these three functions can also be written if you learn only these two functions. But remember one thing: in sine hyperbolic x there is minus, and in sine hyperbolic and in cos hyperbolic x there is plus. So this is the only basic thing which you should know in your mind, and the rest we should move on to our questions. So moving on to question number 1, it's saying sine of cot inverse 1 plus x is equal to cos of tan inverse x. So basically we have to find the value of x. So let's do this question. How can we do this thing? Simply say, since we are getting sine and inside some angle is in the form of inverse function, let's let this inverse function as some a. So that our question gets simplified basically. So basically, I'm letting cot inverse 1 plus x equal to A. Okay. So from here, what I'm getting cot A equal to 1 plus x. Cot A equal to 1 plus x. Okay. So basically cot A equal to 1 plus x, I got it. And we know that, we know the property basically, cosec square x, cosec square x minus cot square x equal to 1. This is a property we use many times in trigonometry. So we will use it here also. Cosec square x minus cot square x equal to 1. So just put the values, you get the value of cosec x. So basically, cosec x is equal to root of 1 plus cot square x. So root of 1 plus x square. So you will get cosec x here. So this is the value of cosec x. And now what you want that you should, take it in line. So basically what I want is you should convert now cosec to sine, so that sine and sin get cancelled out basically. So sine would be 1 upon cosec A, so sine A would be 1 upon root of this thing, which is written here. And similarly, since you want inverse function, so that why we are converting into sine inverse, so that this and this function will get cancelled. That's why. So first we converted cos inverse to cosec inverse, and then cosec into sine inverse, because it is just easy. How we converted cos to cosec using this identity, and then from cosec to sine by just using inverse. So we basically got A equal to sine inverse of 1 upon root of square plus 2x plus 2. We got this thing. So on putting here, sine and sine inverse will get cancelled out, and we will get with this thing. That is 1 upon root of x square plus 2x plus 2. X square plus 2x plus 2. Okay. So you will be left with this thing only. And similarly for cos of tan inverse x, you should do it in the same way. Firstly, change tan to sec, and from sec change it to cos. So basically, changing tan to sec, again we will do the same thing. Sec of b. This sec, since we let it this a, so let tan inverse x equal to b. Let this be equal to b. So x will be equal to tan b equal to x. From the using identity, that's x square x minus tan square x equal to 1. Calculate the value of sec b, you will get this. And converting this, that is cos b is equal to 1 upon sec b, so you will get this. So you get the value of b cos inverse root of 1 upon root of 1 sec square. So cos and cos inverse will get cancelled. That you should you should understand the scope of the question. Why we are doing this question is just to tell you that how you can get rid of bracket. Basically, for sine to get rid of bracket, you should take inverse side. So firstly, we converted cot to cosec and then it to sine. Similarly, here we will convert tan to sec and then sec to cos inverse, so that we will cancel them. So our final question is coming something like this: 1 upon root of x square plus 2x plus 2 equal to 1 to 1 plus x square. And on solving it like normal algebra, you will get your answer as x equal to minus half. Okay. So I hope you understand it. Matlab like square this side. If you are confused at the last step, squaring both sides, what you will get 1 upon x square plus 2x plus 2, 1 upon x square plus 2x plus 2 equal to 1 upon 1 plus x square. Okay, so you will get something like this, and from here you can take it that side, cross multiply basically. So x square cancel out, and what you left with 2x plus 2 equal to 1. So basically 2x will be equal to minus half, minus 1, and from here you can see that it is equal to minus half, which you are getting here. Okay, so I hope you understood the main thing behind the question, how to solve it. So this was the question. Let's move ahead. Okay, so this is an easy question. Number 2. Basically, one more thing, all questions we are solving from JEE-Main previous year only. So don't see that this is a very easy question. These are the questions which came in JEE-Main. So these are actually previous years. JEE-Main. Okay. So what is given 1 plus cot square sin inverse x? You have to tell us the value of this thing. So again, first I told you the first question, whenever some inverse function is given inside some trig function inverse equal to a, letting sin inverse x equal to a. Then from here, take sign that side. So x equal to sin a, x equal to sin a. Okay. Now what you want cot. So try to make cot inside. So basically, again, use this relation cosec square x minus cot square x equal to 1. So we know that cosec a is equal to 1 by x. Cosec a equal to 1 by x. So what would be cot a? Cot a would be root of cosec square x minus 1. That is root of cosec square x minus 1 would be 1 by x square minus 1. That is equal to 1 minus x square by x. I did something wrong. 1 by x square minus 1. So it will be 1 minus x square by x square. Okay. It is like this only. Then from here you will get a equal to cot inverse of this thing. So basically you are getting, okay, you need cot square only, no? So basically square both sides. So cot square a would be 1 by x square minus 1. Okay. So basically you have to add 1 with this thing. So adding 1 both sides. So this and this will cancel out, and your final answer would be 1 upon x square, which you are getting from here. Okay, fairly simple. Just always try to let this bracket be something equal to some a or theta, so that you can easily go ahead with the question. Okay, so moving ahead with this question number 3. What's there in this question? It is written if alpha equal to 3 sin inverse 6 by 11 and beta equal to 3 cos inverse 4 by 9. Where the inverse trig functions take only the principal values, then the right option would be what? Take care. So how can you do this thing? In this question, what you should do is whenever you see this type of question, it should what should strike to your brain is symmetry. So basically here you are getting 6 by 11. So you know that 6 to the 12. So basically try to convert it into 12. And similarly here it is 4 by 9. So 4 to the 8. So convert it into 9. So basically 3 sine inverse 6 by 11 and write 3 sine inverse 6 by 12. Okay. So from here, you know that since you have increased denominator, so overall value will decrease. And overall value will decrease. That this side will be greater than this side. So basically, this thing is there, and you know that this thing is nothing but 3 sine inverse half, and sine inverse half is this thing is equal to 3 sine inverse half. And you know that sine inverse half is nothing but pi by 6. So pi by 6 into 3 is pi by 2. So basically this thing is greater than pi by 2. Alpha is greater than pi by 2. Alpha is greater than pi by 2, which you are getting from here. Alpha greater than pi by 2. Okay. Similarly, solving that one using 4 by 8, you will get beta greater than pi. Beta greater than pi. And since आपको बोला गया है कि you have to know about alpha plus beta also, so alpha plus beta would be greater than pi plus pi by 2, which is 3 pi by 2. Okay, 3 pi by 2. बेसिकली जो मैंने यहाँ पे लिखा है वही मैं आपको समझाने की कोशिश कर रहा हूँ. So alpha is greater than pi by 2 and beta is greater than pi. One thing more, if you are unable to understand, you can draw graph also. Graph of sine inverse x, as I told you, sine inverse x. Or let me copy the graph, it would be easy for you. If I can, let me see. Okay, I can't copy the graph. No problem, let me draw it. It would be something like this. You will go from here to here. It's something like inverse cup. Here it is pi by 2. Here minus pi by 2. Here minus 1. And here it will be 1. Okay. So see here, it is sine inverse 6 by 12. So 6 by 12 will be something here. Sine inverse 6 by 12, no? So you know that this is the domain. So 6 by 12 will be something here. That's it, okay? And 6 by 11. 6 by 11 is small basically. So since 6 by 11 is small, 6 by 11 is greater. Why? Because here denominator is big, here denominator is small. So 6 by 11 will be something here. So you have seen that the value of here and here, which one is greater? This one value is greater. That's why we put a greater than sign here. Then 6 by 12 is nothing but half, and sine inverse half is equal to pi by 3. Just so you know that sine pi by 6, sorry. We know that sine pi by 6 is equal to half. Just that's why sine inverse half is equal to pi by 6, and pi by 6 into 3 is pi by 2. That's why we are getting here pi by 2. Similarly, we are getting here pi, and alpha is greater than pi by 2, beta is greater than pi, and alpha plus beta is greater than 3 pi by 2. Now we can see that since beta is greater than pi, so sine beta is sine beta, and sine pi is nothing but 0. So basically, sine beta would be less than 0. Why? Because beta is greater than pi, no? Since beta is greater than pi, we know that sine pi is 0. And we are saying that beta is greater than pi. Beta is greater than pi, we are saying. And we know that sine pi is 0. So basically, sine beta is less than 0. That's why. Similarly, for cos alpha is less than 0 and cos alpha plus beta is greater than 0. You can similarly do them since we have taken out the main condition of alpha greater than pi by 2, beta greater than pi, and alpha plus beta greater than 3 pi by 2. Okay, so I hope you get that. This is not a tough question. Just you have to use your brain. You can easily do this thing. Okay, so moving on to question number 4. Question number 4. F in f dash x you have been given and you have asked to calculate the value of f1. Okay, so f dash x अपने को दिया हुआ है. So firstly, I told you earlier also when we were studying trigonometric functions, then whenever any trigonometric function is given to you, try to change it into sine and cos. That's why it would be easy. So that's what we did here. We changed sec to 1 upon cos and tan to sec upon cos. So on solving, we will take cos x as cos x as LCM. So we're getting what? We will be getting 1 plus sin x upon cos x. That's what is written here. So basically, what we are getting tan of tan inverse 1 plus sin x upon cos x. 1 plus sin x upon cos x. This is what we are getting. Okay. Now changing sine to sin square x by 2 plus cos square x by 2, it is written here. And sin x will change to 2 sin x by 2 cos x by 2. We know this formula now. We are using this formula here. Sin 2x equal to 2 sin x cos x. This formula we are using here. Sin 2x equal to 2 sin x cos x. This formula has been used. So sin x changes, sin x changed to 2 sin x by 2 cos x by 2 here. And 1 is sin square x by 2 plus cos square x by 2. Similarly, in cos x, we are using this formula, cos 2x equal to cos 2x equal to cos square x minus sin square x. This formula we are using here. Cos square x minus sin square x. Okay, so it would be cos square x by 2 minus sin square x by 2. So from here, since it is nothing but a square plus b square plus 2ab, it would be a plus b square. So it would be cos x by 2 plus sin x by 2 whole square. And denominator is a square minus b square. So it would be a plus b and a minus b. 1 cos x, plus x by 2 plus sin x by 2 will cancel. And you will be left with 1 plus tan x by 2 upon 1 minus tan x by 2. We have done nothing. We have just cancelled 1. That is cancel one thing, and then divide whole equation by cos x by 2. So you will get 1 plus tan x by 2 upon 1 minus tan x by 2. Okay, and this is the formula of tan pi by 4 plus x by 2, because we know that formula of tan a plus b, formula of tan a plus b is equal to tan a plus tan b, tan a plus tan b upon 1 minus tan a tan b upon 1 minus tan a tan b, 1 minus tan a tan b. Okay, so take here pi by 2 plus x by 2, you will get tan pi by 2, which is 1. So 1 plus tan x by 2 upon 1 minus tan x by 2. That's what written here. So here tan and tan inverse would cancel out, and your final answer would be pi by 4 plus x by 2, which is written here. And now, since f dash x is this, so integrate both sides. Integrating both sides, you will get fx equal to pi by 4x plus x squared by 4 plus c. So is a constant which we get after integration. And since f0 is 0, so put the value 0 here. So it would be 0, it would again be 0. So c is nothing but equal to 0. Now for f1, put the value of x here. So it would be pi by 4 plus 1 by 4. C is 0. So our answer would be pi plus 1 by 4, which is your final answer. Okay. So I hope you got that. It is nothing but it is very easy. You have to just use your basic trigonometric and inverse trigonometric formulas, and you can easily reach to your answer. I hope you got that. So let's move ahead to this question. What it is written here is written there that let f be 0, let f be a function going from 0 to 4 pi, and it is saying that from 0 to 4 pi to 0 to pi, and fx is defined by cos inverse of cos x. Fx here, please don't cancel it because domain is not given, so we can't cancel it. Canceling never works always, because canceling always works only when the domain allows. So that's why it is written cos inverse of cos x. Don't take it like x. So please, and what we have asked the number of points of x from 0 to 4 pi satisfying the equation fx equals this thing. Okay, so firstly we have to draw the graph of cos inverse cos x. It is something like this. This type of graphs you should also know. I forgot to keep them in my slides, but basically there are three types of graphs: sine inverse sin x, cos inverse cos x, and tan inverse tan x. At least these three graphs you must be knowing very, like it should be in your it should be in your memory. Cos inverse cos x, sin inverse sin x, and tan inverse tan x. So cos inverse cos x graph is something like this. It goes from here to here and here to here. Similarly, backside. So I drawn cos inverse cos x graph, and fx equal to 10 minus 6 upon 10 graph. So cos inverse cos x graph you should learn. And this graph, let me tell you how we can draw. Y equal to 10 minus x upon 10. So let me take 10 this side. So from here you are getting y equal to minus x upon 10 plus 1. Okay. So from here you can see that your slope is negative. That is, your line is something like this, and slope is minus 1 by 10. So put x equal to 0. So put x equal to 0, you will get y equal to 1. So at x equal to 0, you are getting y equal to 1. See, x equal to 0, y equal to 1. This thing is nothing but 1. And putting y equal to 0, you will get minus x by 10 equal to 1. Basically, x equal to 10. 1 second. So doing it this way, we are getting x equal to 10 when y is equal to 0. Okay, so I hope you got it. So basically, we have drawn this graph using these 2 points, 0, 1 and 10, 0. So stretch a line, and this is cos inverse cosine graph. So what you want that both this equation should satisfy. So you have to just basically find out those points where both the graphs are intersecting. So there is 1 point here, 1 point here, 1 point here, and 1 point here. No, it is not a point because it is not intersecting point. So there are basically 3 points where the graph intersects. And that's what we have been asked, the number of points from 0 to 4 pi. That's why we have drawn the cos inverse cosine graph only from 0 to 4 pi. And it has been asked these are satisfying basically. So you know that 4 pi is nothing but 4 into 3 point something, which is 12. So 10 would come before 4 pi. So if you are confused with that, how to locate points, so you have to just multiply 4 by 3.14, you will get 12. So 10 will come before 12. That's why we are getting 3 points. So my answer would be 3. So I hope you got it. These type of questions are very common in JEE-Main, especially. Basically, what you have to do whenever it is being asked that where these two graphs satisfy, you have to draw those two graphs in the given domain from 0 to 4 pi and see that where these graphs are intersecting. The number of intersecting points are only those points where these two graphs satisfy each other. And since we are getting 3 intersecting points here, so my graph intersects at 3 points. So my answer would be 3 for this question. Okay. So practice these type of questions because these type of questions are very common in JEE-Main. And other is inverse trigonometric function. If you focus on these type of questions, you can easily do these things in your JEE-Main, because inverse trigonometry, very hard questions come in JEE Advanced only. But these type of questions where you have to make graph and solve the function using letting the function of and cutting inverse and trigonometric function, these type of questions are very common in JEE-Mains. So please practice it more. I hope you understood the lecture. So thank you.